Assalamualaikum warahmatullahi wabarakatuh. I'm from Group 7. My name is Muhammad Azim Aika bin Kamaluddin. My metric number is B0920101168. So this is our computer simulation assignment. This is our group members, Muhammad Ali Nazafi bin Isman, Muhammad Fikri bin Naha. For our group program description, stress analysis involves investigating how materials and structures respond to various loads. This analysis aims to understand the impact of forces and external factors on internal forces and deformations. The experiment applies specific pressure and shear loads using steel as the framework material. The result will provide valuable quantitative data, validate models, optimize design, and enhance structural safety. The experiment's outcome will strengthen our understanding of material behavior and inform the design of safer and more efficient structures.
Assalamualaikum. My name is Muhammad Alif Nazafi bin Ismail. My matrix number is B0920101192. So for this presentation, I will be presenting on the modeling parts. So for the first step is modeling. The model are defined. The outer radius of the upper hollow plate is 2 inches. So and the inner radius is 0.5 inches. And the thickness is 0.5 inches. The shaft has a radius of 0.5 inches and the length is 12 inches. And then after that, both the upper plate and shaft are both glued together. After that, we define the material. So the element type with solid 20-1x6 element selected, and the material properties has been defined. So for the young models will be 29733 kips per square inch, and the Poisson ratio will be 0.27. And then to generate the mesh, the shaft line had 23 divisions of mesh. The line on the side of the plate had 2 divisions, and the line on top of the inner circle of the plate had 24 divisions. Then the model was meshed. The hexahedral mesh shape was chosen, and the sweep button was pressed. After pressing the sweep button, the model mesh was created based on the parameter input. And then we go for the solution part. The displacement constraints was applied. The bottom of the shaft was chosen for displacement with zero displacement value. Then the force load was applied. 2 knots along the x-axis chosen with the direction of force Fz, and the load value is 6 kips. And then the moment load was applied. The knot along the y-axis chosen with the direction of force Fx, and the load value is 2.5 kips. And finally, by clicking the current LS, we can obtain the solution. So for the result and discussion part will be explained by my team member Fikri. That's all from me.
Assalamualaikum. My name is Muhammad Fikri bin Naha. My matrix number is B0920101144. And we're going to continue to the results and discussion. First is the theoretical value, which is principal stress is of the max principal stress is negative 38.304 KSI, while the minimum is 23.028 KSI. And then the normal stress at the point H is 15.277 KSI, while the total shear stress at point H is 29.691 KSI. This theoretical value is based on the calculated result. And then the actual value, we got the maximum of principal stress, which is negative 38.3538 KSI, while the minimum is 23.0675 KSI. And then the normal stress at point H is 319.155 KSI, and then the total shear stress at point H is 29.7423 KSI. This the actual value we got inside the simulation. We continue to the discussion, starting with the principal stress. There is slight variation between the theoretical and the actual values of the maximum principal stress and the minimum principal stress. These differences are relatively small and could be attributed to minor inaccuracies in the theoretical model or measurement errors in the experiment setup. However, the most notable disparity arises when comparing the normal stress at point H. In the theoretical calculation, the normal stress at point H is reported as 15.277 KSI, whereas the actual value is significantly higher at 319.155 KSI. Such a substantial deviation suggests a significant discrepancy between the theoretical model and the actual condition. Furthermore, the total shear stress at point H shows a small difference between the theoretical and actual values. This difference, similar to the principal stress, could be attributed to minor inaccuracies in the model or measurements error.